2. Number 2, I have to make a tree diagram and an organized list to represent the sample space. So I'm going to flip a coin 3 times. So I'm going to come up with either heads or tails on my first toss. Here's my second toss. And finally my third toss. So to make an organized list, I'm going to go and follow each path. So this first path, the second path, the third path, the fourth path, for a total of 1, 2, 3, 4, 5, 6, 7, 8 outcomes. So using the counting principle, there are 2 outcomes for the first toss, 2 outcomes for the second, 2 outcomes for the third. So 2 times 2 times 2 is 8 different outcomes. In the next scenario, I need to make 2 choices when I go to the ice cream store. My first choice is, would I like strawberry, peach, or lemon? The second decision I have to make is, do I want it in a cup or in a cone? So all the outcomes in my sample space, strawberry with a cup, or in a cup, strawberry with a cone, peach in a cup, peach in a cone, lemon in a cup, or lemon in a cone. So in my first decision, I had 3 different choices. The second thing I needed to decide it on had 2 different choices. So when I multiply 3 times 2, I have 6 different outcomes. Number 12, I need to determine whether the events are independent or dependent. And if we're talking about spinning a spinner and flipping a coin, we notice that those 2 events have nothing in common, so we say that they are independent. The 2 sets have nothing in common, they are independent of one another. 10 students who ride the bus, 3 students who walk, and 5 who ride a car. Altogether, there are 18 students altogether. If I'm looking for the probability of those that are walking, there are 3 favorable outcomes out of a total of 18, or 1/6. If you're a student who does not walk, that means you ride the bus or you ride in a car. There are 15 students who either ride the bus or ride a car out of a total of 18, which reduces to 5/6. In number 18, we have 12 total. And the probability of selecting a 5 looks to be 2 out of 12, or 1/6. Therefore, the probability of not getting a 5 is the rest of them, 10 out of 12, or 5/6. Number 20 is a review question from geometry in the first semester. And what we're looking at is a 30, 60, 90 triangle. Which is in the shape of a pennant. And the longest side of the pennant is 16 inches, so the longest side would be my hypotenuse. Question is how many square inches of fabric is needed for each pennant? So what we're looking to find when we're trying to find how many square inches is what is the area. So to find the area, I need to multiply 1/2 the base times the height. The base of the triangle times the height. In this drawing, I know neither at this time. So remembering back to the dimensions of a 30, 60, 90, to the relationship of the sides in a 30, 60, 90. If I know the hypotenuse is 16, I find the short leg by taking half. Half of 16 is 8. And to find the long leg, I multiply the short leg by radical 3. So the long leg is 8 radical 3. So the base of the triangle is 8 radical 3. The height of the triangle is 8. So the area is 1/2 of 64 radical 3, or 32 radical 3.